Testing 1, 2, 3. Okay. Hello. Hello. Who is at this computer? Hi, Ashley.
Hi,
How are you?
I'm good.
I like the Christmas lights by the fireplace.
Thanks.
It's a nice touch. You're getting ready for what's eventually coming, huh?
Yeah, there's no light in our living room too, so
Ah, gives you a little bit more light.
Mhm.
Hi, Jordan.
Hello.
How are you?
Good. How are you?
Just fine.
Good.
It's a little bit gray out there today, isn't it?
Yeah, I haven't been outside yet.
Well, I haven't either, but it's like just we've had so much sunshine. We got clouds today. Hi, Caitlin. Hey, Caitlin, do we have sound today? Good.
Yes, Professor.
Oh, good. I just was wondering if the setup was all set to go.
I think it was just a glitch that day.
Yeah. How are we doing here? I guess it's time to get started. Wow, we only have 3 here. Um, well, let me start with, did anyone want to ask any questions yet? Even though we did a whole period of it on 1/6, did any of you have any more?
No, Professor, I don't at this moment.
Okay. Anybody else? Any questions? Well, then I'm going to start the lesson, even though, well, I guess we do have welcome. Let's see, we have Mary now. Hello, Mary.
Hello.
How are you?
I'm good. How are you?
Good. Did you have any questions from last time yet?
No, I think this one I got pretty well.
Okay, good. Well, I'm going to start sharing my screen and we'll start on lesson 1.7 then. Okay, are you guys seeing my screen?
Yep.
Okay, so we'll get rolling. Here's this is probably going to go a little bit quicker today. For one thing, we've already done the questions, and secondly, this is I believe this is going to be pretty routine. Let's see what happens. So, how do you handle inequalities? I'm sure you all know this. There are 4 major objectives. You'll see them there. I don't know if we're going to read them, but there's almost the identical algebra that we have normally. So let's get into an example for me to talk about this. So here's a simple inequality, which I have already solved. Is there anything about that that looks mysterious to you? All I did was what? Start by adding, I wanted to get x alone, so I started by adding 9 to both sides. And then I wanted to, I had to get rid of the multiplied 2, so I divided both sides by 2. I never had to change the less than sign. Why not? Because I never multiplied or divided by a negative number. Remember, that's the only new thing in inequalities, is when you multiply or divide both sides of the inequality by a negative, then you have to change. You have to flip the inequality sign. I'll show you that. There's another oddball thing. How do you check a problem like this? You can't really. You can only what I call it spot check. So, for example, we could pick a number. 13 halves is what? 6.5. So we could just pick a number that is less than 6.5, like maybe 6, and then go back to the top line and try it out. 6 times 2 is 12. 12 minus 9 is 3. Is it true that 3 is less than 4? Yes. So that's not a check, but I call it a spot check. I mean, if you were going to check them all, you'd be going, we'd never get done. Okay. Now, there are different ways to display this. What I wrote is fine. X is less than 13 halves. In the old days, this graph on the left is the way we used to do it. We'd open dot at 6.5 and then shade to the left. This is the new way to do it. Instead of an open dot, meaning don't include it, the rounded parenthesis means up to but not including, and then you still have an arrow. Okay, and then I wanted to show you interval notation too. Well, never mind. Yeah, this is, so there's different ways to do interval notation. This is called, on the left, this is called a closed interval, meaning solid dots on both ends. The square bracket means include the endpoint, whereas over here we have an open interval on the right. And you notice in the old days we would have put open dots. Now we would put these rounded parentheses. So the rounded parentheses mean up to but not including, and the squared off parentheses or brackets mean include the endpoints. I think you knew that, but I just want to make sure everybody understands that. Okay, what happens when you get kind of a double inequality like this one? It's really two inequalities. It's saying -3 is less than 6x minus 1, and then there's a second inequality that says 6x minus 1 is less than 3. And they're both true at the same time. So really, here's how you need to think of it. You need to write out the two separate inequalities. First, the -3 is less than or equal to 6x minus 1. And then secondly, 6x minus 1 is less than 3. And when it's in between like that, it has to be an AND problem. And I don't know if you remember anything about sets, but AND problems, set-wise, you have to take the intersection where the two answers overlap. So anyway, you do the algebra on both sides. Pretty easy algebra. Why did I not have to reverse any of those inequalities? Because I never divided or multiplied both sides by a negative. Take a quick look at the algebra on both sides. Is there any, I mean, that's pretty straightforward, isn't it? But now we got to put these two answers together. Where do these, what's in common between these? They're not the same. We have x is greater than or equal to -1/3, and over here we have x is less than 2/3. So what you do is you kind of put them together. Here's this graph up on top here is kind of the graph of x is less than 2/3. Open dot it. I know you can't see this. Let me just, so this is like 2/3 right here. So it's not equal to 2/3, but it's forever less than it. And then over down below it, I have everything greater than or equal to -1/3. Now the question is, where do they intersect? Where do these two overlap? Answer from here up to an open dot on that end. or I should maybe use the new style. Wouldn't this black thing here be the same as this square? You know, this thing right over here. You could also write your answer this way. Although the book doesn't like these a lot, you can put your answer kind of as a tweener. X is between -1/3 and 2/3, but it's equal on one side and not on the other. And here's the interval notation way to write it. Starting on the left at -1/3 and including the endpoint because of the square bracket, and going up to 2/3, but not including the 2/3 of the rounded bracket. So are those, I don't know, let me know if is that totally new to any of you? I hope not. Okay, let's go on. Try another one here. Ah, yes. What about an absolute value inequality? So we have an absolute, remember, when we were doing absolute value equations, remember what that forced us to do? We had to break the problem into two parts. We will have to do that here too. There's a couple extra things to remember. You're going to have to memorize that absolute value less than problems are and intersection problems, and absolute value greater than problems are or. I'll show you that in a minute. So you break it into two parts, and just like before, on the left side, kind of ignore the absolute value sign. So when I went to the left here, you see how I just dropped the absolute value signs? But now, watch something different here. What did I do in an equation? Remember, all we had to do is change the sign on the non-absolute value side. Look, we had to do something else here. Not only did I change the sign on the non-absolute value side, but I had to reverse the inequality sign from a less than to a greater than. Okay. Well, there's almost no algebra to do here. Add 5 to both sides, add 5 to both sides. So I got two answers again. X is less than 7, and X is greater than 3. Where do they overlap? Well, here's greater than 3. Here's less than 7. Where do they overlap? Between 3 and 7. This is not an ordered pair here in blue. This is actually interval notation for the correct answer. This means start at 3, but don't include the point. End at 7, don't include the point. Everything in between. And here, down below it, is the algebra way to say that. I got a neighbor cutting grass, so give me a second. I'm going to close the window. That's something I didn't anticipate, the neighbor cutting the grass. Okay.
Hey, Professor.
Yes.
So how do you want us to write our answers for the test?
Well,
do you want us to write it?
It depends. First of all, if they ask you to write it as, they're probably going to have you put it in interval notation. So it depends a little bit on the directions.
Okay.
So if they said, give me your answer in interval notation, then you would have answered with this blue thing that right down here. If they would have said, write it as an inequality, then you would write it the black way at the bottom here.
Okay, thank you.
And yeah, and then sometimes they want you to graph it. So that's a good question. You're going to have to watch the directions when you get to those. And I'm trying to go through all of them so you get a little bit more comfortable. Okay, so everybody take a look at this box up here at the top right. You're gonna, this is something you kind of have to memorize. That, by the way, what this stands for here is not 11, but absolute value less than problems. You have to remember are and, overlap, intersection problems, and absolute value greater than problems. You have to remember as or, kind of paste together union problems. You haven't seen the bottom one yet, but I've got one for you on this page. So here's our first absolute value greater than problem right here. Absolute value of x minus 10 is greater than 3. So once again, two parts. Part 1, just drop the absolute value sign. That's all I did right here. Part 2, you have to change the sign on the non-absolute value side from 3 to -3, and you have to reverse the inequality sign. And because this is an absolute value greater than, this one has to be a union, or. And you'll see why. Look what happens when you do the algebra and you get two pieces that don't cross. So if this was an intersection problem, we would write nothing because they don't overlap. But it's not. It's a paste together. So we actually get two parts to this answer. This would be the way to graph it. And then here's, you have no choice to write it in interval notation. You have to write it in two parts. So this, let me put a red arrow here. Well, maybe I can't. But anyway, yeah, this thing right here, this is most likely the way the book is going to want you to write it. In the interval notation. So a union problem generally has pieces that you have to paste together, separate pieces like we have here. Let's see. So let's do a couple. I'm looking in the book now on page 140. So you have your books handy. Look at number 6. Here they just want to get, do you understand interval notation? So do you see how on number 6 they say change this interval notation into an inequality? So here's what the book problem is, and here's how you would write it as an inequality. And it's just, and 2, another one. So do you see why number 2 I had to write this way? See this, it says between 2 and 10, but don't include the 2, no equal sign, but do include the 10 because of the square bracket. So there you notice there's a little half equal sign down there. So why didn't I have to do an in between up here? Because I guess you could say it's in between -infinity and 7, but where's -infinity? Forever to the left. So do you see why you just say that this way? So infinity, I guess you could say, is kind of a cop-out saying, there is no endpoint on that end, it goes on forever. Moving ahead in the assignment, look at number 30. This is number 30. Take a look at the algebra on number 30, and just, I mean, there's nothing unusual there. First thing I did is I multiplied out the 4 times x plus 1 and got 4x plus 4. But then I needed to get the x's together, so I subtracted 2x from both sides. Then I needed to get rid of the 4. I mean, anything unusual there? Pretty straightforward, right? Why did I not have to choose the inequality sign? It's still less than, because I never multiplied or divided by a negative number. So that's the easiest kind of inequality. Okay, let's go to one that's a little different. This happens to be number 38. So here's one of those where you see we have a double inequality. So I had to break this into two parts. Part one is just this part. And part two, so here's part one, and part two in blue is this part over here. Why did I do an and? Because it's in between, it's sandwiched. Then the algebra is pretty straightforward, except that you get two different answers. And what do you... Oh, by the way, here's a good example. Do you see over here on the right, actually on both sides, why did I have to reverse the inequality sign from a less than to a greater than? Because I divided both sides by -3. Of course, that's very important. Likewise over here, why did I reverse this less than or equal to sign? Because I divided both sides by a negative. So then you got to put the two answers together. So I need everything that's bigger than or equal to 1, and I need everything that's, less than or equal to 1 over here, and bigger than -6. So bigger than -6, but never getting beyond 1. Square bracket only on the right, because that's the only side that had to equal. What did the book say for how you're supposed to answer number 38? The directions are solve the inequality and sketch the solution. So this is what you'll find in the back, I believe. You'll see the interval notation answer, and you'll see the sketched graph. Would I mark it wrong if you wrote this? No, but these are the two they're after. All right. Let's go on to the next one. Another one from the book. This time I'm jumping down to 56. So this is a practice problem that involves absolute value. So remember, we got to break it into two parts. First part, just drop the inequality signs. That's what I did over on the left side here. Just drop the absolute values. On the right, I had to do two things. I had to change the sign on the non-absolute value side, and I had to reverse the inequality sign. You see how that's, the inequality sign is the opposite of what it was up here? All right, and then I got to remember this is an absolute value less than. Oh yeah, that's and problem, intersection. Then do the algebra. You wind up with x is greater than 0 over here, because what happens when you multiply by a net? How do you get rid of a multiply -2/3? Multiply both sides by a -3/2. But when you multiply by a negative, you have to reverse the inequality. So this side turned out to be x is greater than 0. The right side, x is less than 3. So here would be your interval notation answer, because there's no equal sign on either side, right? So no square bracket. And then this would be your your sketch. I'll pause for a minute. Are you able to, it's a little bit messy up here. Were you able to follow what I did? Okay, let me know if you need to go back to that, but I'm going to go on. I want to take here's another one from that 50-ish section. This one is number 59 from the assignment. I'm sorry, 58. A little more straightforward. Advice. When should you break an absolute value problem into two parts? Do you remember what I told you with an absolute value equation? I said first get the absolute value by itself. Same here. So this is the way the problem was written in the beginning. Notice there's this non-absolute value part here, plus 3. Step 1, get that out of there. So I subtracted 3 from both sides. Now I have this. Now the absolute value sign's by itself. Now break it into two parts. Again, part 1, just drop the absolute value signs. Part 2, you have to do two things. You change the sign on the non-absolute value side, and you reverse the inequality sign. Okay, now do the simple algebra on both sides. Subtract 14 from both sides. Left side, we get x is greater than 0. Right side, we subtract 14 and we get x is less than negative 28. Now, this is an absolute value greater than, so I have to do an OR union. So what does this look like? So everything greater than 0 looks like this right part here. Everything less than negative 28 looks like this left side. And union says, yeah, put them both in there. By the way, I never did write this in interval notation, so I'm going to do that right now. So this would be this part down here would be your graph answer. And your interval notation answer would be x is greater than 0 in union with x is less than negative 28. Didn't have much room there. This is supposed to be a negative infinity here. Let me try that again. So this would be your interval answer, and this would be your sketch of the graph. Again, let me pause. I haven't let anybody want to follow up on this one or the one before it? Not hearing anything. Speak up though, please. I'd be happy to go back and explain. Okay, I have one more example I'd like to do, and this one comes from, I believe it's number 80. So again, this one is from the last page there. Okay, interesting. You see what number 80 says? The directions above it? Find the intervals on the real number line for which the radicand, that means the thing underneath the root, find the real numbers for which the radicand is non-negative. So do you see how I took the part underneath the radical sign, 6x plus 15, and I made it non-negative? What does non-negative mean? Well, either 0 or bigger. Either 0 or positive. So let me just pause there. Do you see what I did? I took what was underneath, and the book said, tell me when that's going to be 0 or above. So I said, all right, here's my radicand, greater than or equal to 0. I'll solve. Pretty easy. Subtract 15 from both sides. Divide both sides by 6. Simplify the fraction. It didn't say anything about a graph there. So I would leave my answer that way. If we were to write it in interval notation, oh, what's the mistake here? I made one mistake. Can you tell me what it is?
Should it be infinity then negative 5 over 2?
No, because the negative is to the left. Infinity is to the left. But anybody else?
Is it the bracket on the negative 5 halves because it's greater than or
this
equal
should be
to?
There we go. Good job. Okay. Well, that's all I have for examples. Here's what I have for the assignment. Let's see if this makes sense. I don't know of a better way to do it. It's 1 to 89 odds, but I don't want you to do the 61 through 74 section. So there's 2 parts on page 148. Those 2 parts from 61 through 74, don't do those. So instead of listing the problems in 2 parts, I just said do the odds from 1 to 89, but skip that section. So I don't like it when I do all the talking like this, but it's a little bit harder to include everybody online. Any questions, clarifications?
I don't have any, Professor. Thank you.
Thank you. You're always so polite. Anyone else? Anything you want me to take a look at? Explain a little bit better. Well, I look forward to seeing you guys tomorrow morning. Thank you. I'll have to edit this video, and then I'll... oh, just a question. Did any of you use the second link in the email I sent you? You know, there were 2 links this time. Did you see that? There was this really long link on the top, and then I put another one in there just in case. I know we don't have enough here, so it's not too full. But did anybody try clicking the second link?
I opened it.
And you are...
And it worked fine.
And you're in.
Cena.
Yeah.
Yeah.
And I see...
But then I noticed that it was only like 8 people, so I figured I would go in the video.
Oh, so you clicked on the first one then?
Yeah.
Okay. I was just curious. I'm trying to get over that, that over 10 thing, and I guess we don't have enough here. 1, 2, 3, 4, 5, 6, 7, 8. We have 9 people here in addition to me today, so we didn't have that issue. Well, thanks again, everybody. God bless. Have a good day.
You too, Professor.